right, finally we are up and running. All right, so let's talk about translations. So we have seen that reflections were one type of rigid motion. We learned about that last class. And today, another type of rigid motion is going to be a translation. A translation is really just a slide. You're not flipping the image, you're not rotating it, you're not doing anything, you're just sliding it to a different position. So everything about the image stays the same. The pre-image stays the same, the size stays the same, the shape stays the same, everything stays the same, except we're just shifting it, we're sliding it to a different location. All right, so we're going to bring in some high school into this. So it is convenient to describe translations using the language of vectors. A vector is a quantity that has both direction and magnitude. The initial point of a vector is the starting point. The terminal point of a vector is the ending point. The vector at the right may be named vector. So what a vector looks like, the symbol for it. Oh no, tell me it's working, please. Are we not working today? There we go. We're working. We're just delayed. All right. So the symbol for a vector is just 1/2 part of the arrowhead. So it's just like a ray, but only the top part of the ray, if that makes sense. That's a vector. Or it could just be named with one letter with the vector symbol over it. Okay, so a vector has direction. What does that mean? When I say that we're talking about vector EF, that means I'm starting at E and I'm going to F, but my terminating point is F. So there is a length there. It's not like a ray. Can we measure the length of a ray? No, we can never measure the length of a ray. But a vector does have length, but it does have a starting point and an ending point. So some people relate it to a segment. They're like, well, a segment has a start point and an end point and it has a length. That is true. It is similar to a segment in that sense that it has a start point and it has an end point. The difference is a segment doesn't have direction where a vector does have direction. So if I had a segment, let's say I had segment EF, would it matter if I wrote EF or FE for a segment? Does the order matter? No, because the direction doesn't matter. Where for a vector, it absolutely matters. So if I have vector, EF, that means I'm starting at E and ending at F, versus if I have vector FE, what does that mean? I'm starting at F and ending at E. So that's the difference between a vector and a segment. A vector has direction. All right, a vector can also be named using components. Components are sort of like little triangle brackets and then 2 units of measurement. So for example, if we're looking at the diagram to the right, if I'm looking at vector PQ, we're saying to get from P to Q, I'm going to move horizontal 5 units, but then I'm going to move up 3 units. So that's what the component form tells us. So the first one tells us the direction we're moving in the X. The second one tells us the direction we're moving in Y. Okay, so let's look at the diagram to the right. To name a vector, we're going to identify the initial point and then the terminal point. So looking at this, how do I know which one is the terminating point versus the initial point? Any ideas? Any guesses? Connor?
The initial point is M and the terminal point is N.
You got it. The arrow always points to the terminal point. So if our terminal point is N, that means our starting point has to be M. So our initial point is M, our terminal point is N. And if we're going to name this vector, you draw your little half arrow, And then you always start with your initial point and end with the terminal point. So now to write a vector in component form, we're going to write our horizontal change first and then the vertical change. So we're saying, looking at this, to get from M, frozen again, to get from M to N, my horizontal shift is 1, 2, 3, 4 units to the right. And then aren't we going to go 1, 2 units down? So the horizontal changes 2. Now that vertical change, did we go up 2 units or down 2 units for the vertical change? Didn't we go down 2 units? So that, oh, sorry, I wrote 4 here. This is 2. Sorry, I wrote 2. That should be 4. So now for the vertical change, did we go up 2 units or down 2 units? Down. So that's a -2. So our component form is sort of the triangle brackets, 4, -2. Okay, so my question to you is vector xy the same as vector yx? Why or why not? Olivia? Good. Is this the same? No. The vectors have different directions. So now my next question is vector AB different from segment AB? Yes or no? Is vector AB different from segment AB? How many people say yes, it is different? How many people say no, it is not different? Okay, good. Yes, it is different. Vectors have direction. And segments do not. We all get this? Okay. So we can use vectors to describe translations. So if we go here, what I'm highlighting in yellow, this is saying the transformation along vector v of p gives us p prime. So if we're going to take point P and we're going to translate it along vector v, we will end up with p prime. That's how that translates. And let me show you how we can use vectors to translate things. So we can translate along a vector using component form. So for example, if I'm translating along the vector 3, -4, what does that mean? Every point, every pre-image point, I'm going to move 3 units to the right and 4 units where? Down. That's what this means in component form. All right, so just to recap, we last time learned one format. Today we learned another. So the V brackets is component form. And then remember last class we learned about coordinate notation. So it's like the parentheses yields more parentheses. That's the coordinate notation. All right, let's translate using component form. So it says, draw the image of the triangle under the translation of -3, 2. So what I'm going to do is I'm going to take every point in my triangle and I'm going to translate it along this vector. So when I translate it along this vector, every single point is going to move 3 units to the left and 2 units up. So 1, 2, 3, 1, 2. And then 1, 2, 3, 1, 2. And 1, 2, 3, 1, 2. And now here is my image after the translation along the vector -3, 2. Oh, I didn't do this, but before drawing the image, predict the quadrant of the image will lie in. When we have quadrants, just to recap, I know you learned this in middle school, it goes counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, quadrant 4. So which quadrant did we end up in? Quadrant 2. So now they want us to list out the image coordinates. So 0 minus 3 is -3, 3 plus 2 is 5. 1 minus 3 is -2, -1 plus 2 is a -1. And then -1 minus 3 is a -4, -1 plus 2 is a, oh sorry, that should be a +1. That should also be a +1. +1. All right, I want you guys to try this independent. Draw the image of the figure under the given translation of 3, -2. We don't have to worry about question 2 or 3. I just want you to translate it, that's all. All right, what should we have done? We should have translated each point 3 units to the right and 2 units down. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Oops, I only want 1 down. And then 1, 2, 3, 1, 2. There we go. How many people got that? Great. All right, let's keep going. So now we want to name the vector and write the component form for the vector. So remember, we need our initial point first, then our terminal point. Which one in letter A is our initial point? Charlie. G. And then we're going to H, and the way you do it is you draw your little half arrow above it. But not only did I want to write the name of the vector, I want to write it in component form. So those are the little V-shaped brackets. So let's see, from G to H, I am moving 1, 2, 3, 4, +5 units to the right, and then 1, 2, 3, 4 units up. All right, let's look from, can somebody tell me how am I going to name this vector, letter B? How will I name letter B? Good. Vector JD. And now the component form, am I moving left or right at all? So what number do you think I'm going to put there? 0. And then I'm moving down 1, 2, 3, 4. So it's a -4. All right, you guys do letter C on your own, and then we'll go over it. Okay, so this is vector. Who's got it? Who's named this for me? How would we name this vector? Mariana? You got it. VS. We're starting at V. We're ending at S. And then from V to S, aren't I going 1, 2 units to the left? Since I'm going 2 units to the left, is that a +2 or a -2? Adam? -2. So since we went to the left, that's -2. And then I'm going up 1, 2, 3 units. So that's a +3. How many people got that correct? Awesome. All right, let's keep going. So now what we want to do is draw and label the vector with the given information and component form. All right, so we're starting at M, we're ending at P. It doesn't matter where you start. It doesn't matter where your initial point is. So I'll just say that this is M, and then I'm going to go 3 units to the right, 1, 2, 3, and 1 unit down. So there's the P, and then I draw an arrow pointing from M to P. All right, you guys try letter B on your own, and then we'll move on. All right, so here we have -3, 0. So we're starting at C, we're going towards B, but I'm moving to the left. So my initial point, I'm going to start it more to the right, just so I have room to move to the left. So we're starting at C, and then we're going 3 units to the left. 1, 2, 3. Am I going up or down at all? No. So this is my point B, and it looks like this. How many people got that? Great. All right, so that's the end of translations. Now let's talk about rotations. So we have seen that reflections and translations are 2 types of rigid motion. Can somebody refresh my memory? What does it mean to be a rigid motion? Milo? Good. We preserve distance and angle measurements. So basically your pre-image and your image have to be congruent. The final rigid motion we will consider is a rotation. A rotation turns all points of the plane around the point called the center of rotation. The angle of rotation tells you the number of degrees through which points rotate around the center. Alright, so the figure shows 120 degrees counterclockwise rotation around point P. When no direction is specified, you can assume the rotation is counterclockwise. This is a big deal. When no direction is specified, you can assume the rotation is counterclockwise. So if I just say rotate this 90 degrees, I mean rotate it 90 degrees counterclockwise, the opposite say rotate this, 270 degrees, that means a 270 degrees counterclockwise rotation. We're not going to investigate anything, and we're not going to create anything, so basically we don't care about any of this stuff. We don't care about this stuff. We're going right here, rules for rotations. So now I'm giving you the rules for rotations, 90 degrees, 180 degrees, and 270 degrees. All of these rotations, are we clockwise or counterclockwise? 90, 180, 270, clockwise or counterclockwise? Always counterclockwise, unless I specify something different. Always counterclockwise. So the rule for a 90-degree counterclockwise rotation is if I give you xy, you're going to negate the y and then switch x and y, which we had some practice with this last class. Right? Now, 180-degree rotation is saying keep x and y where they are, but negate them both. That's a 180-degree rotation. And then a 270-degree rotation, you're going to negate the x and then switch x and y. Are we ready for some practice? Yeah? Okay. So now we are going to draw this image under a 270-degree rotation. When we do a 270-degree rotation, is it clockwise or counterclockwise? Counterclockwise. So let's just take an estimate. Let's estimate where we think, a guess, where we think we're going to end up. So we agree if we're going to do a 90-degree rotation, it would end up in quadrant 2. Then 180 would end up in quadrant 3. So then 270, which quadrant? 4. Does that sound about right, that we should end up in quadrant 4? All right, let's see what happens. Let's list all of our pre-image coordinates. So here, let's call this A. I have the point 0, 2. And then B, we have the point 1, 2, 3, 1. And then point C, I have the point 4, 2. And then point D, here, I have the point 1, 4. Now the rule for a 270-degree rotation is xy yields y negative x. So what I'm going to do is I'm going to negate the x and switch x and y. So my A prime is going to be negate the x. Well, can I negate a 0? No, but can I still switch to 0 and 2? Absolutely. So we're going to have 2, 0, which is right here. And then letter B, we're going to negate the x, so I'm going to negate the positive 3. So my B prime is going to negate the positive 3, then switch x and y. So this ends up becoming 1, negative 3. And then C prime, again, I'm going to negate the 4, then switch the 4 and the 2. And last but not least, can somebody tell me, what will my D prime be? Mariana? You got it, 4, negative 1. Then we connect it. And there